deep beneath the rolling waves of the Pacific Ocean, just off the coast of Oregon, something massive is breathing. It is not a creature of flesh and bone, but a giant of rock, magma, and sheer tectonic power. Right now, as you are listening to this, the seafloor is rising. Scientists monitoring the axial seamount, the most active submarine volcano in the Northeast Pacific, have just confirmed a data point that is sending ripples through the geological community. The volcano's inflation level has officially hit 95%. This is not just a statistical milestone. It is a warning sign etched in the crust of our planet. For months, the scientific consensus pointed toward a potential event in 2026. But the recent acceleration of ground deformation suggests that the window for a major eruption has just swung wide open much earlier than anyone anticipated. We are looking at a countdown that has moved from years to potentially months or even weeks. To understand why this matters, you have to picture the axial seamount. It is located about 300 miles west of Cannon Beach, Oregon, sitting squarely on the Juan de Fuca Ridge. It is a gateway to the Earth's mantle. Unlike volcanoes on land that we can see and smell, submarine volcanoes operate in a world of crushing pressure and eternal darkness. Yet, thanks to an intricate network of sensors known as the Ocean Observatory Initiative, we have a front-row seat to this geological drama. This network spans the seafloor with fiber optic cables, pressure sensors, and seismometers, feeding real-time data to laboratories on land. And that data is screaming. The ground at the center of the volcano's caldera has risen nearly 3 meters since its last major event. When a volcano inflates like a balloon reaching its breaking point, it means the magma chamber below is gorged with molten rock, pushing against the ceiling of the crust with unimaginable force. Now, why is 95% the magic number? Geologists have spent decades studying the patterns of axial seamount. It erupted in 1998, then again in 2011, and most recently in 2015. By analyzing the behavior of the volcano before those past events, researchers discovered a strikingly predictable pattern. The volcano seems to have a specific threshold of inflation. Think of it like a rubber band being stretched. Every time it reaches a certain length, it snaps. For axial, that snap happens when the caldera floor reaches a specific height relative to its post-eruption level. We are now at 95% of that historical snapping point. In previous cycles, the final 5% of inflation often happens with a sudden surge in seismic activity and a rapid acceleration of ground movement. We are entering the red zone, the phase where the pressure looks for any weakness in the rock to force its way out. The implications of this early window opening are vast for our understanding of marine geology. For a long time, the deep ocean was a mystery, a place where eruptions happened in total isolation, undetected by humanity. But axial changed that. Because it is so active and so well monitored, it has become the world's premier laboratory for underwater volcanism. If it erupts now in 2024 or early 2025, it challenges our previous models of magma refresh rates. It tells us that the Earth's internal plumbing system is moving faster than we calculated. The heat flux and the rate at which magma is rising from the mantle into the shallow reservoir are increasing. This isn't just about one volcano. It is about understanding the pulse of the tectonic plates that govern the very surface of our world. Let's talk about what actually happens during an event like this. When an underwater volcano at this depth erupts, it is rarely an explosive blast like Mount St. Helens. The immense weight of miles of ocean water acts like a lid on a pressure cooker. Instead of a plume of ash rising into the sky, we see the birth of new land. The result is a violent but contained interaction that creates glass-like rock formations known as pillow lava. This process releases massive amounts of chemical energy and heat into the surrounding water. It creates what scientists call megaplumes, huge bubbles of warm, mineral-rich water that can rise hundreds of meters above the seafloor. These plumes are like life-giving storms in the deep sea. They carry nutrients that trigger massive blooms of deep-sea bacteria, which in turn support an entire ecosystem of strange, alien-looking creatures that survive without a single lick of sunlight. But there is a catch to this early window. If the eruption happens now, we have to ask ourselves what is triggering the acceleration. Is there a shift in the Juan de Fuca plate that is allowing more magma to bypass the normal bottlenecks? Or is the magma itself changing, becoming more gas-rich and therefore more buoyant? the sensors are currently picking up a steady increase in micro-earthquakes. These are tiny tremors, often unfelt by humans even if they were standing right there. But to a seismologist, they are the sound of rock breaking. Every tiny pop and crack recorded on the seafloor is a signal that the roof of the magma chamber is failing. As we approach that final 5% of inflation, these earthquakes will likely transition from a few dozen a day to hundreds or even thousands. This is the seismic scream that precedes the final breach. One of the most fascinating aspects of this discovery is the role of the Ocean Observatory Initiative. Before this cable was laid, we would only find out about an eruption months or years after the fact, when a research vessel happened to sail over the site and noticed the seafloor had changed. Now we see it in milliseconds. The speed of light through fiber optics allows us to watch the volcano's heartbeat. Scientists can actually hear the sound of the lava moving through subterranean tunnels. This real-time capability is what allowed the team to pinpoint the 95% inflation mark so accurately. It is a testament to human ingenuity that we can monitor a mountain 2 miles under the sea with more precision than we monitor some mountains on land. What does this mean for the people of the Pacific Northwest? For those living along the coasts of Oregon and Washington, there is no immediate reason for panic. Axial seamount is deep enough and far enough offshore that an eruption there does not typically pose a tsunami risk. Unlike a massive landslide or a subduction zone earthquake, a fissure eruption on the seafloor rarely displaces enough water to send a wave toward the coast. However, it is a reminder of the incredible tectonic activity that defines the region. The Juan de Fuca Plate, which Axial sits upon, is the same plate that is being pushed under the North American continent, creating the Cascadia subduction zone. While Axial is a constructive boundary where new crust is being made, its behavior provides critical clues about the health and movement of the entire plate. Monitoring the pressure at Axial is like checking the pulse of the Cascadia system. As the 2026 window opens early, the scientific community is scrambling. Oceanographic research vessels are being rerouted to the area, or AUVs, are being prepped to dive into the fray. These robotic explorers are essential because they can get close to the action without risking human life. They can swim through the hydrothermal plumes, taking samples of the water to check for changes in CO2 and sulfur levels. An increase in these gases would confirm that the magma is very close to the surface. We are also looking for changes in the temperature of the hydrothermal vents, the black smokers that dot the volcano's flanks. These vents often show a spike in temperature days before the main event. Let's dive deeper into the chemistry of this phenomenon. A dark, dense rock that makes up most of the ocean floor, but the way it interacts with the seawater is a masterclass in chemistry. When the eruption starts, the rapid cooling creates volcanic glass, or obsidian. Tiny fragments of this glass can be carried miles away by ocean currents. If we can capture these fragments during the early stages of the eruption, we can read the history of the magma. The bubbles trapped inside these glass shards are like time capsules, holding samples of the gases that were present in the Earth's mantle millions of years ago. This is why the early window is so exciting for researchers. Every day that passes is an opportunity to prepare the instruments that will catch these microscopic clues. But there is also the biological side to consider. The axial seamount is home to some of the most resilient life forms on Earth. Tube worms, giant clams, and specialized crabs live in the shadow of the volcano, dependent on the chemicals emitted by the vents. For them, an eruption is a dual-edged sword. While the molten lava can pave over entire communities, the new heat and minerals provide the foundation for the next generation. We have seen in previous eruptions how quickly life returns. Within years, the cooling lava flows are covered in white mats of bacteria, followed by the larger animals. Observing this process in real time, especially if it happens sooner than expected, will give us unprecedented data on the speed of biological succession in extreme environments. The acceleration of the inflation rate is also a puzzle for the mathematicians. Modeling a volcano involves thousands of variables, from the viscosity of the magma to the elasticity of the surrounding rock. If the 95% mark has been reached ahead of schedule, it means one of those variables is behaving differently than predicted. Perhaps the rock ceiling above the magma chamber is thinner or more brittle than previously mapped. Or perhaps the rate of magma injection from below is not constant, but comes in pulses. Understanding these pulses could help us predict eruptions at other, more dangerous volcanoes around the world. Every piece of data from Axial is a lesson that can be applied to places like Iceland, Hawaii, or even Italy's Campi Flegrei. We must consider the sheer scale of the energy involved. An eruption at axial can move cubic kilometers of rock. The heat released in a single event is enough to power a continent for weeks if we had any way to capture it. It is a reminder of the raw, primal power of our planet. We live on a thin crust, floating over a sea of molten metal and rock. Most of the time, we can forget that fact. But when a giant like axial begins to stir, when the inflation hits that critical 95% threshold, we are forced to pay attention. We are reminded that we are guests on a dynamic, changing world. The early opening of the eruption window also has technological implications. The Ocean Observatory Initiative's cable is a delicate thing. It sits on the seafloor, prone to the very eruptions it monitors. Some instruments were actually buried by lava. Scientists had to wait to see if the data would still flow. Remarkably, most of the network survived, providing a play-by-play of the volcano's internal collapse. This time, the team has deployed even more rugged sensors, some designed to be sacrificed to the lava for the sake of getting that last, crucial data point. The bravery of these robotic sensors allows us to stand in the heart of the fire without getting burned. What should we be watching for in the next few weeks? The first sign will be a seismic swarm. This is not just a few earthquakes here and there, but a continuous drumbeat of tremors. This indicates that the magma has finally breached the main reservoir and is carving a path toward the surface. Next, we will see a sudden drop in the inflation. This seems counterintuitive, but as the lava begins to exit the chamber and flow onto the seafloor, the pressure inside drops, and the caldera floor actually begins to sink. This is the moment of truth. If the sensors record a rapid deflation alongside a massive spike in water temperature, we know the eruption is underway. The curiosity surrounding axial seamount is not just restricted to geologists. Space agencies like NASA are also watching closely. Why? Because the conditions around underwater volcanoes are the closest thing we have on Earth to the icy moons of Jupiter and Saturn. Like Europa and Enceladus, these moons are thought to have vast oceans beneath their icy crusts, heated by volcanic activity on their seafloors. If we can understand how life thrives on the axial seamount, we can better design the missions that will one day search for life in the outer solar system. The early eruption at axial could provide a testbed for the types of sensors NASA hopes to send to those distant worlds. There is also a sense of urgency in the scientific community because of the funding and logistics required for deep-sea research. Ships like the R. Seth Thompson or the Roger Revelle are often booked years in advance. An unexpected surge in volcanic activity creates a logistical nightmare. Scientists are currently negotiating for ship time, trying to find any available vessel that can carry the ROVs, or remotely operated vehicles, needed to document the event. There is a frantic energy in the marine science departments from Seattle to San Francisco. No one wants to miss the chance to see the seafloor change in real time. As we continue to monitor the inflation, we have to recognize the beauty in this process. The creation of new crust is the fundamental heartbeat of our planet. It is how the continents move, how the oceans stay mineralized, and how the Earth regulates its internal temperature. Axial seamount is a vital part of that cycle. Even if it erupts early, it is simply the Earth doing what it has done for 4 billion years. Our ability to see it, to measure it to 95% accuracy, is a new chapter in our history as a species. We are no longer just observers of the Earth's power. We are chroniclers of its most intimate rhythms. The data pouring in from the Pacific Northwest is a reminder that science is never settled. It is a living, breathing field where new discoveries can overturn old timelines in an instant. The 2026 window was a best guess, a model based on the past. But the volcano doesn't care about our models. It follows the laws of physics and thermodynamics. If the pressure is there, it will move. And that is exactly what we are seeing. The pressure is there, the rock is groaning, and the ocean is waiting for its next great transformation. For those of you fascinated by the strange and the wonderful in our natural world, the coming months will be a period of intense discovery. We will see maps of the seafloor redrawn. We will see new thermal vents appear where there was once only cold rock. We will likely see new species of bacteria or strange symbiotic relationships formed in the heat of the eruption. And we will see it all, because we decided to put eyes and ears at the bottom of the ocean. Stay tuned as we watch the final 5% of this inflation cycle. Every millimeter of rise is a story. Every earthquake is a signal. The axial seamount is about to remind us once again who really runs this planet. It is a giant beneath the waves, and it is waking up early. The window is open, the magma is moving, and the world of deep-sea science is about to get a whole lot more interesting. We are at the edge of our seats, waiting for that final breach, the moment when the Pacific floor opens up and the Earth pours itself into the sea. This is the frontier of discovery, happening right now 300 miles off the coast of Oregon. It is a testament to the fact that there are still mysteries being solved and new worlds being born right here on our own blue planet. Looking at the history of axial, we can see how far we have come. In 1998, we were lucky to find the remnants of an eruption. In 2011, we caught the tail end of the signal. In 2015, we saw the beginning and the middle. But in 2024 and 2025, we are ready for the whole show. We have better cameras, more sensitive microphones, and a faster connection to the deep. We are about to witness an event that would have been invisible to our ancestors. And we are going to learn more about the interior of our planet than ever before. As the seismic activity continues to climb, researchers are also looking at the regional context. The Gorder Ridge to the south and the Explorer Ridge to the north are also showing signs of restlessness. Is the entire ridge system entering a more active phase? This would have massive implications for our understanding of plate tectonics. If the mid-ocean ridges are accelerating their production of crust, it could mean that the subduction zones on the other side of the plates will also have to process that new material faster. It is a global game of tectonic Tetris. An axial seamount is one of the most important pieces of the puzzle. There is something profoundly humbling about knowing that 95% of the pressure is already built up. It gives us a sense of the inevitable. You can't stop a volcano, you can't relieve the pressure, and you can't look away. All you can do is watch and learn. This is the essence of scientific discovery. It is the pursuit of understanding things that are far greater than ourselves. The axial seamount is a colossus, and its early awakening is a gift to the curious, a challenge to the scientists, and a reminder to all of us that the Earth is a vibrant, active, and unpredictable home. The coming weeks will likely bring more announcements as the 96, 97, and 98% marks are hit. Each one will bring more telescopes and sonar arrays to bear on that single point in the Pacific. We are watching a countdown that is controlled by the mantle itself. When the eruption finally happens, it will be a spectacle of fire and water, a clash of extremes that defines the very geology of our world. And thanks to the modern era of marine research, we will have the best seat in the house. So as we keep an eye on the inflation data and the seismic swarms, we invite you to stay curious. The Earth is still full of surprises, and some of the biggest ones are happening right now, miles beneath the surface of the sea. The axial seamount is rising, the window is open, and the story of our planet's next great eruption is being written in real time. It is an incredible time to be watching the world, discovering the hidden forces that shape every continent and every ocean. The countdown is on, and the deep sea is about to put on a show we won't soon forget. Every update brings us closer to the heart of the volcano, and every piece of data brings us closer to understanding the great, fiery engine that hums beneath our feet. The 95% threshold is just the beginning of the end of this cycle, and the start of a whole new era of discovery in the deep Pacific. Stay alert, because the Earth is moving, and it is doing so right on our doorstep. The early opening of the 2026 eruption window is a call to action for every mind that wonders what lies beneath the waves. It is time to listen to the volcano.